guys, this is Ms. Kissinger, and we are going to start working on section 6.1b. We are going to try to use this picture and what we know about slopes and distances to figure out which type of quadrilateral this is. The first thing I want to do is name off all the quadrilaterals that we have done so far. Our first one that we did was a parallelogram. Now, our parallelogram means that we have two sides that are parallel. The two opposite sides specifically are parallel. Our next shape that we had was a rhombus. And a rhombus tells us that it's a parallelogram and all the sides are congruent. The next one we talked about was a rectangle. Then we talked about a square, which we both know what a rectangle and a square are. Our next one is a trapezoid. And then we have a special kind of trapezoid called an isosceles trapezoid. And then we have a kite. Now hopefully you remember all of the properties of these so that this will be easier for you to figure out. Now, the first thing we're going to do, in my opinion, is to label our points so that we can name them something. So we have point A, point B, point C, and point D. Now I'm going to actually write what the points are. So my point A is going to be over 1 to the right and up 2. So my first point is 1, 2. My B point is over to the right 3 and 1, 2, 3 up. So I have 3, 3. My C point is 1, 2, 3, 4, 5, 1, 2. So we have 5, 2. And my D point is 1, 2, 3, and up 1. So we have 0.31. Okay, now the first thing it tells me to do is find my slopes. So we need our slope formula, which is m equals y2 minus y1 divided by x2 minus x1. We should know this. We have used this before in slope-intercept, and we have found the slope between 2 points. So now we're going to use it again to figure out which type of quadrilateral this is. Okay, first line segment. Let's just do AB. And remember, this is our x1, y1, and x2, y2. So we're going to do line segment AB. We're going to find the slope. So we have 3 minus 2, because we have our y2 minus our y1, divided by x2, which is 3, and our x1, which is 1. So our slope is going to be 3 minus 2, which is 1, divided by 3 minus 1, which is 2. So our slope of this line here is going to be 1/2. Now we need to find the slopes of all of these other lines. So, next one. We are going to do BC, but first, let's go ahead and erase our x1 and x2 and y1 and y2 just so we don't get confused on our values. So now we're going to do point BC. So we have our x1, y1, x2, y2. So we have, don't forget your line, we have y2, which is 2, minus y1, which is 3, divided by x2, which is 5, minus x1, which is 3. So we have 2 minus 3, which is negative 1, divided by 5 minus 3, which is 2. So our slope of this line here is going to be negative 1/2. Now let's move on to our next piece. Let's erase our little values right here so that, again, we don't get confused. So we have, now we're going to do segment CD. So we're going to say this is our x1, y1, and our new x2, y2. Notice that I'm labeling these every time. I don't want to get confused because if I mess something up, then the whole problem is going to be ruined. So I have CD. So I have y2. So I have 1 minus y1, which is 2. So 1 minus 2 divided by my x2, which is 3, minus my x1. So I have 1 minus 2, which is negative 1, and 3 minus 5, which is negative 2. And remember, negative divided by negative is the same as a positive. So I have positive 1/2 as my slope over here. So this side has a positive slope of 1/2. Now we just have one more little piece to do for slopes, and then we can move on and make some judgments about these. Okay. And our last one, we're going to do segment AD. So we have x1, y1, x2, y2, and we're going to do segment AD. Now, the reason I have to do all of these is because I have to know the slope of all of them in order to decide if any of them are parallel or perpendicular or what. So I have y2, which is 1, minus y1, which is 2, divided by x2, which is 3, minus 1. So I have 1 minus 2, which is negative 1, and 3 minus 1, which is 1 minus 2 is negative 1. 3 minus 1 is 2, sorry. So my slope for this piece here is going to be 1/2. Now let's think back to our properties. We know that a parallelogram has two sets, or the opposite sides are parallel. Now, to be parallel, that means they have to have the same slope, which we just found. So, is 1/2 the same as 1/2? Yes. So we have one side of parallel lines, and then is negative 1/2 the same as negative 1/2? It is also true. So we know that it's some type of parallelogram. Now we know these are all a rhombus, a rectangle, and a square are all parallelograms too. So I can cross out trapezoid, isosceles trapezoid, and kite because I know that those are not parallelograms. So now I need to figure out if it's a regular parallelogram or if it's one of these things. Now, I can tell that my angles aren't congruent because that's an obtuse angle and that's an acute angle. So I know that it's not going to be a rectangle or a square because both of those have congruent right angles. But I can look at these distances right here and decide if they are the same and decide if it can be a rhombus. Now, I only have to test one with the positive slope and one with the negative slope, because if these are both congruent, then these two have to be congruent. So let's do our two distances and see if we can come up with any sort of solution. The first thing we need to do is decide what our distance formula is. We did a review of it yesterday and we learned it last semester, so again, you should be a pro at this by now. Our distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. You are going to have to use this chapter, so make sure you remember this if you didn't memorize it the first time. First thing we're going to do is our distance of AB. So we have our x1, y1, and x2, y2. So AB distance, now remember when we're talking about distance, we do not put our segment line over it. It's just the two letters. So we have AB equals the square root of x2, which is 3, minus x1, which is 1 squared, plus, parenthesis, we have y2, which is 3, minus y1 squared. So now we can say that equals 3 minus 1 is 2 squared, and then 3 minus 1, or 3 minus 2, I'm sorry, is 1 squared. So now we have the square root of 4 plus 1, which equals the square root of 5. So our distance for AB is the square root of 5. Now we need to find our distance for BC and decide if they are the same, because if they are not the same, then it can't be a rhombus. But if they are the same, then we are in business. So we are going to do BC. So let's do x1, y1, and x2, y2. And we have BC is equal to the square root of our x2, which is 5, minus x1, which is 3 squared, plus y2, which is 2, minus y1, which is 3 squared. Now we can say 5 minus 3 is 2 squared, plus 2 minus 3 is negative 1 squared. So we have equals the square root of 2 squared, which is 4, plus negative 1 squared, which is negative 1 times negative 1, which equals positive 1, which equals square root of 5. So yes, these two sides are congruent. So that means that these sides are congruent too, since all of these are parallel. And we can say that our shape is a rhombus, which is exciting. Okay, now let's do the same thing, except this time we need to actually plot our points. So, it says, what is the best way to classify quadrilateral ABCD with vertices A negative 3, 3, B 2, 4, C 3, negative 1, and D negative 2, negative 2. So, let's plot point A, which is 1, 2, 3, or negative 3 up to 3. So here's our A. And then B is 1, 2, 1, 2, 3, 4. There's B. C is 1, 2, 3, negative 1. And our D is going to be negative 2, negative 2. So we have our other point here. Oops, and this point is a little off. It was supposed to be 1, 2, 3, 1, 2, 3. Here, I was off one coordinate. So we have our A, we have our B, we have our C, and we have our D. Okay, now let's make our lines so that we can make some accurate decisions. So we have lines going here and here and here and here. Now, we can figure out the slopes of these a little bit faster than we did before. We can just count. So we have AB, our slope is going to equal the rise over run. So we are going to go up and then over. So we are going to go up 1 in this case and over 1, 2, 3, 4, 5. So we have 1/5 as our slope. And then we have BC, which we are again going to do rise over run. Now we are rising downward, so we're going to be negative 1, 2, 3, 4, 5, and positive 1. So we have negative 5 over 1 slope. Then we need to do CD, which is going to be rise 1 downward. So we have negative 1 divided by, and we're going to go backwards 1, 2, 3, 4, 5. So we are at negative 5, so our slope is positive 1/5. Don't forget your line. And then we have AD, which is rise 1, 2, 3, 4, 5. So we went up 5. And then we had to go back 1. So we had negative 5 here. And negative 5 divided by 1 is negative 5. Now, notice our slopes. We have negative 1/5, or positive 1/5, and positive 1/5. So that means these two sides have to be parallel, which is awesome. Now we have negative 5 and negative 5, which means these two also have to be parallel. Now, the other cool thing is that we know that if these are perpendicular, that this is a right angle. Perpendicular, again, remember, means opposite reciprocal. So if we have 1/5 as our slope, our opposite reciprocal is going to be our opposite. So this is positive, so it's going to be negative. And then our reciprocal means flip the sign. So we're going to have 5 over 1. So this is 1/5, and this is negative 5, which means that AB and BC are perpendicular to each other. So that means we have a perpendicular line here, a perpendicular line here, because we have negative 5 and 1/5. And then our lines CD and AD, we have 1/5 and negative 5, so we know this is perpendicular, and this one is perpendicular. So far so good. We know that it's a rectangle. Now it looks kind of to me like it's a square, so we're going to test our distance formula and see if we can know that it's a square. So let's do our distance from A to B, and let's do x1, y1, x2, y2 for our 2 points. And remember, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So far, so good. So now we have our square root. Remember, we're finding the distance of AB. We have the square root of x2, so we have 2 minus negative 3 squared plus y2, which is 4, minus y1, which is 3 squared. Now remember, minus and negative makes both of these positive, so we have the square root of 5 squared, because 2 plus 3 is 5, plus 4 minus 3 is 1 squared. 5 squared is 25 plus 1, which equals the square root of 26. Now we can leave it like this because we're cool like that. So now we need to figure out our distance from B to C. So let's go ahead and erase these and relabel. So now we have x1, y1, and x2, y2. We better write these down here because I'm going to have to scroll up. So we have 2, 4 is our B, and our C is 3, negative 1. And we had x1, y1, and x2, y2. And now we can scroll down. And then this is in the way. Sorry. Okay, now we're in business. Okay, so we have our distance, and we are doing our distance for segment BC, and we are hoping that it's the same so we can say that this is a square. So we have BC equals the square root. Don't forget you're not supposed to have that line there. Equals x2 minus x1. So we have 3 minus 2. 3 minus 2 squared plus y2 minus y1. So we have negative 1 minus 4 squared. So it equals 3 minus 2, which is 1 squared, plus negative 1 minus 4 more, so it's negative 5 squared. So we have the square root of 1 plus negative 5 squared is negative 5 times negative 5, which equals 25, which equals the square root of 26, meaning that this line is congruent to this line, and these ones have to be congruent as well. So we have a square. Now, I want you to do this next problem and bring it into class tomorrow, and we are going to do it together once you get into class, but I want to make sure you saw this video. Okay, moving on. Now we're going to use algebra to find missing angles and links. The first one is the rust is a parallelogram. Now, if I were to extend these edges out this way, if I have my marker, extend these edges out, that was not very good, like this, then we would look like we had two parallel lines that were cut by a transversal, meaning that this is, or these two angles are same side interior angles, and we know that same side interior angles add up to 180 degrees. So that means I can say 2x minus 10 plus 3x plus 50 is equal to 180 degrees. Now we can combine like terms, so we have 2x and 3x, which is 5x, plus a negative 10 plus 50, which is 40, equals 180. Now I'm trying to solve for x, so I'm going to subtract 40 on both sides. So I have 5x equals 140, divide by 5, divide by 5. So I have x equals 28. Now, if x is equal to 28, then that means I can figure out what these values are. So I have 2 times x, which we know is 28, minus 10 for this one. So 2 times 28 is 56. So then we have 56 minus 10, which equals 46 degrees. So I know that this angle here is 46 degrees. Now I do the same thing here, and I'm going to do 3 times 28 plus 50 is equal to 84 plus 50, which is 134 degrees. Now don't forget your degree symbol. You have to put it on both of these. But that is how we figure out the degrees of our parallelogram. We have already kind of done this before, so hopefully you were able to follow along easily. Now our next one. We are doing the swag, and it is a rhombus. And the fancy thing that we know about a rhombus is all of our sides are congruent. So I can solve for A and B just by setting the two equations that have A in them equal to each other, and the two equations that have B in them equal to each other. So to solve for A, I'm going to do 5A plus 4 is equal to 3A plus 8. I'm going to subtract 3a from both sides. So then we have 2a plus 4 is equal to 8 minus 4 on both sides. So I have 2a is equal to 4. Divide by 2, and a is equal to 2. Now, the only thing left I have to do is solve for b. Whoa. And b is going to be 3b plus 2 equals 4b minus 2. So I'm going to subtract 3b from both sides. Now you could have subtracted 4b from both sides. It does not matter. So then we have 2 equals b minus 2. And I'm going to add 2 to both sides. So then I get 2 plus 2, which is 4, equals b. So my b is equal to 4. And a is equal to 2. And this concludes our lesson for tonight. So hopefully you understood everything, and I will see you in class tomorrow. Be ready to ask questions and to work on homework.